Namaskar. With this video, we will start linear combination of random variables. Today, we will understand the concept of linear function of a random variable. Suppose x is any random variable, continuous or discrete, and a and b are two constants. Any constant. Okay. The condition is that a can be negative, can be positive, b can be negative, 0 or positive. Okay, if this is the case, then ax or x plus b or ax plus b, all these three things are basically a linear function of the random variable x. Linear function of x. They in turn become a new random variable. Okay. Now this x basically will have its own mean or expectance, and it will have its own variance. So if that is the case, then we need to find what will be the mean of ax or variance of ax. Similarly, if we have to find what will be variance of x plus b or mean of x plus b. So how do we find this particular thing? To understand this, let's take an example. Suppose x is a discrete random variable and it's having some sort of distribution like this. Capital X is taking values 1, 2, 3, 4, and probability of x taking these particular values, let me just bring this to the right little bit. Okay, so taking these particular values is 0.1, 0.2, 0.3 and 0.4. This is the distribution of this random variable x. Now if I have to find out the mean of x, so what do we mean by mean of x? It will be summation of probability of x taking the value x, small x, into that small x value, correct? So this is equal to what? This is equal to 1 into 0.1 plus 2 into 0.2 plus 3 into 0.3 plus 4 into 0.4. If I solve all this, what do I get? I get this value something as equal to 3. This is the expectance of this random variable x. This expectance, I can write it like this also, mu with the suffix x, for our convenience, because I'll be using this notation. Now, similarly, if I have to find out the variance of x, so what is variance of x? Variance of x is expectance of x square minus of square of the expectance of x, correct? So this becomes equal to what? This becomes equal to summation of x square into probability of x taking the small value x minus mu of x ka square. Okay, so this will be equal to what? This will be equal to 1 square into 0.1 plus 2 square into 0.2 plus 3 square into 0.3 plus 4 square into 0.4 minus of mu of x ka square. So mu of x is what? 3. So this will be 3 ka square here. So if I solve this, what do I get? I get this value as 1. This is variance of x. This variance of x, for my convenience, I'll write it as summation, this one, sigma x square. Okay. Now this we have studied in the lower grade. Let's try to understand. Suppose y is a linear function of x given by x plus 4. Okay. So this y basically is a new random variable. So for this particular y, what will be the probability distribution? This is the probability distribution of x. So for y, what will be the probability distribution? Here, whatever the x is, we're taking the value to that particular value, we will add a 4. So 1 will become 5, 2 will become 6, this will become 7 here, and 8. So now probability of y taking these values will be what? This probability is not going to change. This will be 0.1, 0.2, 0.3, 0.4, correct? So now if I have to find out mu of y, or expectance of y here. So what do we get? This will be equal to summation of y into probability of capital Y taking the value small y, correct? So this will be equal to what? 5 into 0.1 plus 6 into 0.2 plus 7 into 0.3 plus 8 into 0.4. So if I solve this, what do I get? I get this value as equal to 7. Okay, but this 7 is equal to what? Can I say this 7 is equal to 3 plus 4? Can I say this? If I can say this, so that means, can I say that mu of y is actually mu of x plus 4? Okay. Similarly, if I have to find out variance of y, so variance of y will be equal to what? I'll write it as sigma square with the suffix y. This will be equal to what? Summation of y square into probability of y taking the value small y minus of mean square of the mean of y, correct? So this will be equal to what? This will be equal to 5 square into 0.1 plus 6 square into 0.2 plus 7 square into 0.3 plus 8 square into 0.4 minus mu y square, so that is 7 square. So if I solve this, what do I get this value as? I get this value as y 1. So that means sigma square y is basically 1. Okay, so this is actually equal to what? This is actually equal to sigma x square, correct? So that means if I am scaling up the value of x by 4, then what happens? I get this particular relationship, that expectance of y basically here, which is nothing but expectance of x plus 4, becomes equal to expectance of x plus 4. If you can see this here, correct? And variance of y, which is nothing but variance of x plus 4, becomes equal to variance of x. So that means there is no change in the variance when the random variable x is added with some constant. Okay, so in general I can write this as, if y is equal to x plus b, then e of y basically is equal to e of x plus b, and variance of y is equal to variance of x, correct? This is one relationship which we have got. Now let's try to understand one more thing. Let's take a new page. Suppose w is another random variable, okay, or a linear function of the random variable x. Then if I have to find out the mean and the variance of w, I should know the probability distribution of w. So what will be the probability distribution of w? This w will take now values what? 5 times whatever the value x is taking. So it will be 5 into 1, that is 5, 5 into 2, 10, 15 and 20, correct? Because x was taking values 1, 2, 3 and 4. So here probability of w taking these values will be equal to what? Let me bring it to the right little bit. So this becomes equal to, probability will remain the same. Probability here is not going to change. This is 0.2, 0.3 and 0.4, correct? Now if I have to find out mu of w or the expectance of w, so what it will be? It will be summation of w into probability of random variable w taking the small value w, correct? So this will be equal to what? This will be equal to 5 into 0.1 plus 10 into 0.2 plus 15 into 0.3 plus 20 into 0.4, correct? So if I solve this, what do I get? I get this equal to 15. Okay, so this is equal to 15. Can I write this as 5 into 3? I can write this as 5 into 3, correct? But 3 was what? 3 was the mean of x or the expectance of x. So can I say that expectance of w is 5 times into the expectance of or the mean of x, correct? Or e of w here is 5 times e of x. Okay, Now suppose we have to find out variance of W. So again, variance of W, what it will be? This will be equal to sigma square of W. Basically, this will be summation of probability of W taking a small value W into W square minus of mu of W whole square. Correct? So this will be equal to what? This will be equal to 5 square into 0.1 plus 10 square into 0.2 plus 15 square into 0.3 plus 20 square into 0.4 minus mu of W square. So that is 15 square or square of 15. So this is equal to what? This, if I solve, I get this as equal to 25. Okay. This 25, can I write it as 5 square? Or in turn, can I write it as 5 square into 1? I can write it as like this, correct? But what was 1? 1 was equal to the variance of x. So can I say this is equal to 5 square into variance of x? Correct? So that means here variance of W is equal to 5 square into variance of x. So in general, can I say E of W, which is equal to E of say A into x, is actually equal to A into E of x, and variance of W is equal to variance of AX, which will be equal to A square into variance of x. Correct? Can I say this way? Okay. So this becomes the second relationship when we have a linear function which is a multiple of a given random variable. Okay. Now can we combine the two concepts? Suppose if we have a linear function which is a multiple of the random variable plus some constant, like I can have y is equal to a times x plus b. Correct? So in that case, the expectance of y will be equal to what? Expectance of ax plus b. Correct? So this in turn you can understand as that it will become expectance of ax plus expectance of b. Expectance of ax, we got it as a times expectance of x. Correct? But the mean of b basically will remain it as b only. So here I can combine the two results which we have studied till now. The first one here and the second one, this one. Let me bring both on one screen. Let me take a screenshot of this. Let me go to the next page. Let me bring it here. So this is what we have studied these two together right now. So I'm combining the both. So here what do I get? Expectance of y, where y is ax plus b, will become a times expectance of x plus b. Similarly, variance of y here will be equal to variance of ax plus b, which in turn I can understand this way. This becomes variance of ax plus variance of b. But variance of ax is a square into variance of x, and b being a constant, there will be no change in b. So the variance of b basically will be 0. So I can write it as variance of y is equal to a square into variance of x. Correct? Let me bring it here. Okay. So this is the third property of the linear function of any random variable, which we need to understand. Okay. Now if we have to apply linear function concept properly, we need to understand the distribution of the random variables. So to understand one of the distribution, please watch the playlist coming in front of you in next few seconds. Radhe Radhe.